Hello guys. The next topic what we are discussing is page replacement algorithm that comes in your memory management. See, normally in your page replacement algorithm, before going with that, you all know that any process has to be executed, it should be brought into which one? Yeah, your main memory. Just consider there is something process P1. Okay, this is your process P1. And you have your main memory. You have your main memory, and normally what happens is any process has to be executed, it should be brought to which one? Yeah, your main memory. As you know that the main memory, whatever it is there, it is finite, means it is fixed size. Sometimes what happens is the process what you are executing, it can be larger than what? It can be larger than your main memory. Whenever that is the case, you can accommodate only what? One or two process. You can't go with a concept called as multi-programming. So for that case, what you are doing is, you are going with a concept called as virtual memory. Virtual memory is what? That is larger than your physical memory. That is an illusion of your main memory. And here what you are doing in your virtual memory, something called as demand paging. Something called as what? Demand paging. So here what exactly you are doing is, instead of storing the entire process into your memory, only whichever the part of your process you need, only that particular part will be loaded into your memory. That's it. On demand, during execution, whichever the part of your process it need for execution, only that will be loaded into your memory. And here to do that, the process, whatever it is, that is stored in which one here? That is stored in your secondary storage. That is stored in your secondary storage, means your hard disk. It is divided into equal size blocks. It is divided into what? Equal size blocks that are called as pages. That are called as pages. For every page, there will be what? The page numbers. For every page, there will be a page numbers. You are dividing the process into equal size blocks called as what? Pages. Every page is being associated with what? Page numbers. Okay. Same way, the main memory, whatever it is there, it is divided into equal size blocks, and those are called as what? Frames. Those are called as, and the main memory is divided into equal size blocks called as what? Frames, and every frame have what? Frame numbers. And normally what happens is, any process executes, the pages has to be loaded into what? Your frames. Any process has to be executed, the pages has to be loaded into what? Your frames. That is a funda. Hope you are clear with this. And here normally what happens is, if you are going with multiple programming concept, and in that particular case what happens is, whichever the particular page that is needed at that particular moment of time, those pages will be stored in your memory, or those particular pages will be stored in which one? Yeah, in your frames. Now assume that you want to insert one more process will come and it want to insert some pages, but there is no space available. There is no space available. Assume that it is already stored. Page 1, page 2, page 3, page 4. Now I want to insert page 5, but there is no space here. At that time what should I do is, I need to select one particular victim page. I need to select one victim page and swap out that particular page out of your main memory to secondary storage, and swap in the desired page which want to enter your main memory. So here, whatever the page that is been selected as a victim for replacement, to swap in the new page into your main memory, so for that you are going with what? Different types of page replacement algorithm. Different types of page replacement algorithm. And in your syllabus we have 3 different types of page replacement algorithm, namely FIFO, LRU, and something called as optimal. And here normally what happens is, whenever you want to insert the particular page into your memory, you will check whether the page is present or not. If page is present, no, not it is easy task, continuous execution. If page is not present, what do you need to do? You need to insert that particular page into your memory. So whenever you are inserting the page into your memory, that is called as page fault. Whenever you are inserting the page into your memory, that is called as what you can say is page fault. Whenever the page is not in memory, and inserting the particular page into your memory, that is called as what? Your page fault. Very much needed. Okay, so first we'll go with your first algorithm, FIFO. Okay. Here we'll go with your first example, first in first out. The question will be as follows. Consider the following page reference string. So these are the page reference string. Okay, so what do you mean by this 701 and all? These are your page numbers. So this is what the CPU is asking the particular pages to be inserted into what? To be inserted into your main memory. How exactly you are going to insert these pages into your memory? And this is in this particular order. First is requesting for page number 7, next page number 0, next page number 1, like that. So totally there are how many strings? Means there are totally 20 strings. Okay. And they said that for a memory with how many frames are there? Your memory consists of only 3 frames. How many page fault would occur for FIFO, LRU and optimal, they asked. So first we'll go with this an example. So this is the reference string. You write in sequence and you write a box that is nothing but your memory. So I'll say there are 3 frames. So this is your frame 1, frame 2 and frame 3. At a time you can insert only one page. So normally first page is what? 7. I'll check. Before inserting, I'll check whether the particular page is in your frame or not, in your memory or not. If it is not there, I'll insert that particular page. Whenever I insert, that is called as what? Page fault, or it is called as page miss. Okay, now 7. Nothing is in your memory, instead is there. I am going to insert. It is not in your memory. So whenever I insert, that is called as what I can say is page miss or page fault. Page fault is there. At a time only one page can be inserted. Next, out of 3, 1 is full, still 2 and 3 frames are empty. Okay. So now 0. Whether 0 is in memory, 0 is not in your memory, then I need to insert that. Okay. So 7. So 0 will be inserted into frame number 2. Hope you are clear. And this also called as what? Page miss or page fault. Next, what is the next page number? 1. Is it in memory? No. I am going to insert that particular page in memory, then that is called as what? Page miss or your page fault. Whenever you are inserting page into memory, that is called as page fault. Now next you can understand here. Now your memory is full. Memory is full. And you want to insert the next page. So page number is which one here? 2. 2 is in memory, 2 is not in memory. So for that, what are you going to do? You need to go for replacement. Means I need to select one page in your memory, I need to swap out and I want to insert what? The demanding page. So for that, I am going with which one? FIFO. First algorithm, first in, first out. So whichever the page that came first into your memory, that will be replaced to swap out and swap in the new page. So here, in 701, the oldest page, which page came first? 7 came here, 0, only 2, 1 here. So which page came first? 701, your page number 7 came first. So what you do is, the new page, whatever it is, that has to be replaced with what? The old page, which came first. Means 7 will be replaced. Okay, and inserting a new page. Again, you replace your page, that is called as what? Page miss or page fault. I'm just making an into mark, whichever page fault occurs. 0. Yeah, you can understand here. See here. 0 is already in memory. Next what? Page number it want, page number 0 it want. But it's already in memory. So then what you will do is, you don't go for replacement. That is called as page hit. That is called as what? Page hit. Hope you are getting, that is called as what? Page hit. I am not replacing. If all the particular page, if it is already in memory, don't go for replacement. That's it. So next page. 3. Is it in memory? You have to check the previous one. Is it in memory? No. In 201, which page came first? 2 here it is there, 1 here it is there, 0. So which came first in 201? 0 came first. So what you will do? You will replace, swap out what? 0 and swapping which one here? 3. That's it. And again you will replace the page. What is that? Page miss or page fault? 0. You should not check the older one. Here only you have to check the previous one. 0, it is in memory? No. Present situation I have to check. 0 is not in memory. In 231, which came first? Here it is there, here it is there. 1 came first. So what you will do? You swap out 1 and replace with what? Swapping with what? 0. Again page replace is done. that is called as page fault or page miss. Next page is which one here? 4. It's not in memory. Go for page replacement. FIFO it is in 230. 0 is here, 3 is here. Which came first? 2 came first. So swap out page 2 and swap in which one here? Page 4. That's it. Again your replace, that is called as page fault or page miss 2. Okay, same way. It's not in memory. Go for replacement in 430. Which came first here? 4 here it is a, 3 came first. 0 here it is a. So what you will do? You will replace 3. Swap out page 3 and swap in which one here? 2. That's it. Again page replace. That is called as page fault, or it can also be called as page miss. 3. You check your previous page, previous frame, not there. You have to go for replacement in 420. Which came first? 4 here it is a 2. Just now it came. 0 came first. So what you will do is swap out 0 and swap in which one here? 3. Page replace. That is called as page fault or page miss. 0. I'll check. Not in memory. In 423. 3 now came. 2 here it is a 4 came first. So swap out 4, swap in which one here? 0. Again page replace, that is called as page fault or page miss. 3. Already in memory. What happens? It is page hit. Don't go for replacement. Already it is in memory. So 3 is already in memory. Don't go for replacement. 2. Already in memory. Again it is what? Page hit. You are not replacing. Whenever you are not replacing, that is called as page hit. Hope you are clear. 1. Not in memory. You have to replace in 0, 2, 3. Which came first? 0 here it is a, 2 here it is a, 3 here it is a. Which came first? 2 came first. So what I will do? Swap out Z2 and swap in which one here? 1. That's it. Replace the page. That is called as page fault. 2. Not in memory. Check. So what I will do? In 0, 1, 3. Which came first? 0 here it is a, 1 just now it came. 3 came first. 3 came first. So swap out which one? 3 and swapping which one here? 2. Again replace the page, that is called as page fault. Hope you are getting right. So 0 already in memory. Don't go for replacement. That is called as what? Page hit. 1 already in memory. Don't go for replacement. That is called as what? Page hit. 7 not there. You have to replace in 0, 1, 2. Which came first? 0 here it is a, 1 here it is a, 2 here it is a. Which came first? 0 came first. So replace, swap out which one here? 0 and swap in which one? The new page 7. Hope you are clear. This is called as replace. That is called as page fault or page miss. Next 0. Not in memory. Replace. What do you do? In 7, 1, 2. Which came first? 7 just now it came. 1 here it is a, 2 here it is a. Which came first? Your 1 came first. So swap out 1, swap in your 0. That again replace, that is called as page fault. Again 1 not there in your memory. You have to go for replacement in 7, 0, 2. Which came first? 7 here it is a, 0 just now it came. 2 came first. So what you will do? Swap out the page 2 and swap in the page 1. And again you replace, that is called as page fault. Guys, hope you understood. I know they ask what is your page fault, or it can be called as what? Page miss. Count which other into is there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Page fault is what? 15. If you want to calculate the miss rate, page miss rate, 15 divided by total number of string, it is 20 into 100. That you get what? The miss rate. And now if they ask hit rate, hit rate means you are not going for replacement, straight mark whatever done. 1, 2, 3, 4, 5. So 5 divided by total number of pages, that is your 20 into 100. That is what? Hit rate. Means you are not going for your replacement. So that's it. So normally you have to specify what is your page fault for your FIFO. For your FIFO, page fault is 15. That's it. So this is the answer. This is the answer. Hope you are clear with this, guys. So next I will go with your LRB. Sometimes they may ask